Let's explore a dendrogram and see how it works. Here is the dendrogram created on our country cluster data from the first lectures. We've chosen this example as you know it so very well. This solution has been produced on the same data set based on longitude and latitude, and we have standardized the variables. By the way, standardization did not make a difference in this case. Okay, so each line starts from a cluster. You can see the names of the countries at the beginning of those lines. This is to show that, at the start, each country is a separate cluster. The first two lines that merge are those of Germany and France. According to the dendrogram, these two countries are the closest in terms of the features considered. At this point, there are 5 clusters. Germany and France are one, and each country is its own cluster. From this point on, going up, Germany and France will be considered one cluster. Now, here's where it becomes interesting. The next two lines that merge are those of the Germany and France cluster and the UK. At this point, there are 4 clusters. Germany, France, and the UK are one, and the rest are single observation clusters. At the next stage of the hierarchy, Canada and the US join forces. The next step is to unite the Germany, France, UK cluster with the Canada-US one. Australia is still alone. Finally, all countries become one big cluster representing the whole sample. Okay, cool. What other information can we get from the dendrogram? Well, the bigger the distance between two links, the bigger the difference in terms of the chosen features. As you can see, Germany, France, and the UK merged into one cluster very quickly. This shows us that they are very similar in terms of longitude and latitude. Moreover, Germany and France are closer than Germany and UK, or France and UK. The USA and Canada came together not long after. However, it took half of the dendrogram to join these 5 countries together. This indicates the Europe cluster and the North America cluster are not so alike. Finally, the distance needed for Australia to join the other 5 countries was the other half of the dendrogram, meaning it is extremely different from them. To sum up, the distance between the links shows similarity, or better, dissimilarity between features. All right. Next on our list is the choice of number of clusters. If we draw a straight line piercing these 2 links, we will be left with 2 clusters, right? Australia in one and all the rest in the other. Instead, if we pierce them here, we will get 3 clusters: North America, Europe, and Australia. The general rule is, when you draw a straight line, you should count the number of links that have been broken. In this case, we have broken 3 links, so we will be left with 3 clusters because the links were coming out of those 3 clusters. Should we break the links here, there will be 4 clusters, and so on. Great! Finally, how should we decide where to draw the line? Well, there is no specific rule, but after solving several problems, you kind of develop an intuition. When the distance between 2 stages is too big, it is probably a good idea to stop there. For our case, I would draw the line at 3 clusters and remain with North America, Europe, and Australia. Okay. When most people get acquainted with dendrograms, they like them a lot. And I presume that is the case with you, too. And indeed, they are pretty cool, but not cool enough to have more than 2 or 3 lectures in this course. Let's see some pros and cons. The biggest pro is that hierarchical clustering shows all the possible linkages between clusters. This helps us understand the data much better. Moreover, we don't need to preset the number of clusters. We just observe the dendrogram and take a decision. Another pro is that there are many different methods to perform hierarchical clustering, the most famous of which is the Ward method. Different data behaves in different ways, so it is a nice option to be able to choose the method that works better for you. K-means is a one-size-fits-it-all method, so you don't have that luxury. How about a con? The biggest con, which is also one of the reasons why hierarchical clustering is far from amazing, is scalability. I will just show you a single dendrogram of 1,000 observations, and you will know what I mean. 1,000 observations, and the dendrogram is extremely hard to be examined. You know what else? It is extremely computationally expensive. The more observations there are, the slower it gets, while k-means hardly has this issue. All right, in the next lesson, we will see some really cool visualizations of clusters, and we will begin practicing. See you there!